Hey guys, it's Steven from Legit Tech Tutorials, and this is a little change of pace. This is a physically shot video. Sorry for the mess on this table. I really need to clean it up. But so this is Shredder episode like 31. So we could finally show you guys where all our hard work has gone. So here is the Shredder that we have designed, and we have done a little bit of modification when we were going to the manufacturer to manufacture this component. And so this is a laser cut. This is obviously a laser cut version, not a water jet version. So it's extremely precise. It's really nice. We do have some issues, so I'm going to talk about that. But I wanted to do this as it was kind of a first for this channel, so that we design something and then you see it actually built in real life. Because now I've been in industry before, mainly, well, semiconductor, but I know what it's like to design something and never see it built, so I wanted to not do that. So I'm basically adding this so that doesn't happen. So when we design something, we could see it in physical form and see how it operates, and also what could be changed or improved so that the machine operates better. So this is again all laser cut 1/4 inch. You guys remember the design. It weighs about 25 pounds. Extremely heavy, and you see our nice gears here on the component. Sorry, on the shredder itself, and you can see the tolerance here that this guy comes on and off pretty easily. So it just slides on, and you can see. So yeah, you can see there. And then these two gears basically sync up the shredder blades, and I assembled it exactly like you saw me assemble it in the CAD. I do the back side first. Let me show you the back side. So let me go ahead and pop the camera off here. Stand by. So here's the back side. You can see the two spacers that are stacked on top of each other that adapts the square shaft into the 6006 ZZ ball bearing. You can see there, and then that's pressed into the bearing support and then welded. So basically what I do is I start out with that. I start out with pressing these two guys onto the shaft. And again, the tolerances are nice and loose so that this goes on really easily. So you just press those guys on. You press those guys on, push the bearing over it, push this plate over it, and push the bearing support onto it, and then you have it sit on the table with these two shafts sticking straight up. And then what you do, let me go ahead and reinstall back here. Then what you do is you alternate. So you see here that this one has a shredder dial that's pressed against the backing, and then this one has a gap. So it alternates. So it's shredder, gap, shredder, gap, shredder, gap, shredder, gap, right? So and then you can see that it is properly now indenting. So so technically when you're cutting, only one blade is contacting at a time. So right now this blade has already contacted, well actually this one down here, then this one, 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 this one, this one, this one, etc. over and over and over again. So that is correct. It looks really nice, and that's exactly how it's supposed to be. So when you assemble it, there are certain numbers that have been laser etched onto the blade faces that you put in succession, right? So I believe it's 1 1 2 2 3 3 4 4 5 5 5 6 6, and then 1 1 2 2 3 4 3 3 4 4 5 5 6 6. And obviously after every one of these you're going to put a spacer in between, and let me go ahead and show you guys that as well. Stand by. So this is what it looks like on the inside. So there you can see the spacers in between. So spacers in between each dial. So you basically assemble those that way, and you assemble them up, and then you see that this one has the blade that's against the wall, and then on the other side it has a spacer that's against the wall here, and this one's alternate. So this one has the blade against the wall on this side, as you can see, blade on the wall this side, and then this one has a spacer, and over here it has a spacer while this one has a blade on the wall. And then once you have those assembled where everything looks good, then you put the cap here on. So then you place the cap on, and when you place the cap on, then you put the bearing in, and obviously you're gonna press these two square to circle bearing adapters here, just like on the back side. You place those two onto this shaft, you press the bearing onto it, and then you put this plate on it, and obviously you're going to do the same on both sides. Then you put the plate on, and then you put the bearing support on, and then you put the gears on that you match, and then you have to match the teeth up so that the teeth are matching. So you're going to have to probably wiggle it a little bit until you get the until you get the gears to mesh, and the point where these blades are even on height. You can see here that they're basically overlapping each other in the same exact position. So then you have to match up the blades that way, and you sync those blades up after you put the two gears on. And then you put the half moons, I call them. You slide those in from the side, and then you use clamps like these. You clamp it from the side, and then you clamp it with these guys off. You clamp it on the bearing support. So it's clamped this way and clamped this way together, and here you want to make it literally as tight as you can on something like this. Eventually I'm going to modify one of these clamps so that I could use a torque wrench, and so I could, when I'm assembling these, I could do it at the same torque every time. And then I do that so that we can so that we take any of the tolerances out here, so it's very tight. And I've seen that I didn't tighten it as much, so you could actually get a 15 thou feeler gauge over here in the corner, and it'll actually tighten everything up. So I didn't tighten it as much as I should have. And then because this is a 3/4 shaft, you could use a 3/4 wrench to drive it. And you can see I have some plastic in there. So I've been messing around with some 3D printed plastic. So you can see it run here, and you can hear that it's crunching some plastic. And I have quite a bit of stuff stuck, all piled up underneath, so it's picking that stuff up and running it back through. Here you can see here's a piece of water bottle. So let's see if we get it to do some. Here's a thin piece of PLA, a 3D printed part. So let's put it over here in this corner. And there it goes. Let's load in another piece, and let's get you guys a top-down view. So let's rotate this guy back around. Then now you can see the rest of it went down in the bottom. This guy's still a little too big, so this guy would probably be gone around again. So we can put it up at this blade height here. And so even if it falls on these are so tight that it will basically shear the plastic anyways, even if it doesn't go to the blades. The blades are just to pull the material down. So some of the issues with this guy that need to be fixed is that if you notice, I don't know if you can see it, is that they rounded the blades, they deburred the blades and they rounded the blades so the blades aren't square, so it doesn't cut as well. That's one thing, and I need to clamp it harder next time, and I need to have something that holds the bearings in because the bearings are super loose. So yeah, I need to add something for that. So that's about it. Alright, thanks for watching.